Hello everyone, I want to explain some of the questions from Codeforces round 890 div 2 today. So first of all, a problem tells of a sort. Alpha has an array of positive integers a of length n. Alpha can perform the following operation. For all I from 1 to n, replace ai with the maximum of 0 with and ai minus 1. Alpha will perform the above operation until a is sorted, and that a satisfies a. So this, you know what the sorted is. How many operations will alpha need to perform? Under the constraints of the problem, it can be proven that alpha will perform a finite number of operations. So here you can see the constraints are till 50 numbers, and all of them are under this number, so we can draw it. First of all, for this first case, why this is 0? Because if you see 1, 2, 3, 1, 2, 3, you can see 2 is bigger than 1 and 3 is bigger than 2, so that's already sorted, so we just print this 2. So but what about other cases? How we should see the pattern here? So for this case particularly, so here after this is coming 1, so that this part is not sorted. To do this, we should perform one operation here, so and it's not still sorted, so we can perform other operation. So as you can see here, if it is not sorted, whatever we do, we need to make it all to 0. Not all, but the unsorted part. For example, this 2 was not sorted, so when we did it to the 0, they became sorted. Otherwise there is no possible, because they still will have some difference. So we should make it to the 0. So what is for this case? Why this is 5 and not 3? So as you can see here, this is not sorted part and this is not sorted part. So to fix this part, we can just perform operation 2, 0, 4. Sorry, this part will also automatically be operated, so this is not still sorted. Twice more, 0, 3, 2, 0, 0, 2, 1. So as you can see here, this part is not still sorted, so there is no use to find how many steps we need to sort this part. So we can just start from finding how many steps we need to sort for this part, and this number of steps is this 5. So as you can see, even in this case, so this part is sorted. The biggest unsorted part is this number and 1. So we need number of steps that we need is this number itself. We don't need to consider other cases. So now we will just get all information we need. So first of all, we should keep checking the differences, so whether this is sorted or not. So we will get one integer to save this maximum value. For example, this would be its first maximum value, so we can set it to be 0, and the one value for all previous and now. So we will get previous and others by this loop. So you know what, if you don't know rep, I will just use for. So and this is from 1 to the n. So we can get it. So now we can get this now, and so when it is not sorted, so if this if now is smaller than previous, current is smaller than bigger than previous, so for example 2 is bigger than 1, so that's sorted, otherwise it's not. So this now is smaller than previous. Then what we're gonna do, so we will change value of maximum, and this value will be maximum of the previous maximum and this previous value. So now previous will be now because we will go to the other iteration. So we, at the end we will print MA. So let me check it through a sample case. So as you can see here, it works for a sample case. If you have any problems understanding the logic here, you can write in the comments. I will try to help as much as I can. C++. For problem A. It's running. So it's accepted. So as you can see, it's accepted, and so we can move on to the B problem. Good arrays. You are given an array of positive integers, A of length n. Let's call an array of positive integers B of length B length n. Good if so no two values at the same index should be same for A and B, and if you add all the values of A, it should be equal to B. So does a good array exist? So first of all let's try the case where all values are 1. For example 1, so 1 1 1. Can we make another can we make the good array that's B that's equal to this? So we can do this, and we need to, so we will put 3 here. So you may think that we could do this, but it says positive integers, so we can do nothing like this. So for all, if all of them are 1, we have to just say no, it's not possible. Now can we count all numbers that are equal to the 1? For example, in this case here, number of ones is 1. So and sum of the array is 9. So if we have a lot of ones, a lot of ones, and sum is not big, then what would we answer? Of course no. Otherwise we can just say yes. So you are seeing the logic here. For this case, the number of ones are 1 2 3 4 is 4, and sum is 6. So as you can see, a number of ones number of ones is big, and sum is not that big. So if we subtract n from the sum, it should be at least equal to the sum, equal to the 1, or it can be bigger. If that's the case, we can say yes. Otherwise we will say no. because there would be no chance. For example, for this case, sum is 6. 6 minus 1, 2, 3, 4, 5. It's a 1, and 1 is not bigger than 4. So this would be false, and so our answer is no. So now we should implement this code. First of all, we will have n. So that it fits to the integer. So then an. So we should get all these elements. So let me just use rep, so you can see here what does rep means. So we got all the values, so we should count. So now we should count this number of. So now we should get one variable to count the number of ones. So we can get, now call it ones to be 0, and traverse through this array A. If I equals to the 1, ones plus plus. So we can calculate sum here too. Sum would be 0 also. Sum plus equals this I. So now our main part, here it comes. If sum minus n is greater than or equal to once, we can say it. We can print yes. Otherwise no. So we missed one case here. I will explain now. So you will see it here. We are missing one more case. This case. So as you can see here, for 17 we got yes. Actually, if there is even if it's 999, we cannot say it's yes, because the number because this statement is true, because there only one value, and we cannot do anything except putting this number itself. So we should also check n is bigger than 1. Now this force answer would be no, and it will pass through this sample cases, and we can check with the Codeforces itself. Problem B. So it's running. Let me refresh. So it's accepted. You can try to implement it yourself. Most important thing is to understand logic. So goodbye everyone. Subscribe and stay tuned.